Our second shuffle is also referred to as a pairwise transpose. And that's because the only difference here will be the stacking order, as you will see. So for this shuffle, we begin with an ordered packet 1 through 8, and we're going to now perform this shuffle. Now recall, a pairwise transpose is where you deal the first top 2 cards onto each other. So 1, 2, 1, 2, 1, 2, and then 1, 2. Okay, that is a pairwise transpose dealing of the cards. Now this time we're going to stack 4 on top of 3, and those 4 cards on top of 2, those 6 cards on top of 1. So what we're doing is we're simply stacking from right to left. And something I don't think I made clear with the previous shuffle that we just did, so let me just point it out. In the first shuffle we did in this video, this stacking is simply a description of stacking the piles from left to right. That's all we did earlier. Now we're stacking the piles from right to left, where the numbering of the piles is assumed to be pile 1, 2, 3, 4. So number 4 is over here. So the notation indicates that we stack from right to left. That's the only difference. Now, of course, it will lead to a new ordering of the cards. Okay, so this is the new ordering that we get, and it's kind of a curious one if you look at it. It's simply a packet reversal. So in Cauchy's 2-line notation, our permutation is described as follows. So we have 8, 7, 6, 5, 4, 3, 2, 1 as our new ordering. Writing that in cycle notation, we get the following. 1 goes to 8 and 8 goes to 1. So we get a transposition or a 2 cycle. 2 goes to 7 and 7 goes to 2. So it wraps around. We get a second transposition. 3 goes to 6 and 6 goes to 3. Here is our third transposition. And 4 goes to 5 and 5 goes to 4. So here's our fourth transposition. So whether it's apparent immediately or not, this right here is the cycle notation for a packet reversal of 8 cards. Color coding the numerals 1 through 8, we obtain the following. Recall that positions 1, 4, 6, 7 are color-coded black, and position values 2, 3, 5, 8 are color-coded red. The reason for the color coding is to aid us in detecting whether there's been a wholesale replacement of cards in these positions and they've been moved to these positions. So has there been an inversion is what we call it. So has this occurred? So in the color coding, we can see that black goes to red 8 and red 8 goes to black. Red 2 goes to black 7, which cycles around to red 2. Red 3 goes to black 6, and black 6 goes to red 3. And black 4 goes to red 5, which gets sent back to black 4. So we can see here that each value gets sent to a value of the opposite color. So this is an indication that inversion has occurred. Why don't we quickly demonstrate that using our quintessential Bessey sequence 1001 0110. So what we have shown here is that we should get the inversion of this sequence. So let's perform the shuffle. So once again you deal 1, 2, 1, 2, 1, 2, and then 1, 2, and now here we're stacking from right to left. So what we should get is the inversion. So we should get 0, 1, 1, 0, 1, 0, 0, 1, and we do. So looking at this sequence here that resulted from the pairwise transpose, in which we stacked from right to left, let me just point out the zeros and ones switched places in some fashion. But in particular, what has happened is The first position card, which used to be a 1, got switched with the 8th position card, which used to be a 0. Because right here we see that 1 goes to 8 and 8 goes to 1. Similarly, the second card, which is now a 1, switched places with the 7th card, which is now a 0. So that 0 here used to be here, and that 1 there used to be there. So that's why we have a 2, 7, 2 cycle. And similarly for positions 3 and 6, and positions 4 and 5. Looking at the shuffle diagram for this pairwise transpose, in which we're stacking from right to left, we get a diagram that is identical to one that's coming up later in this series, namely Shuffle 47. And as indicated, this shuffle that we've just performed is equivalent to just reversing the order of all of the cards. Doing so leads to this Bessey shuffle diagram. There's a double arrow between 1 and 8. There's a double arrow between 2 and 7. Also a double arrow between 3 and 6, and finally a double arrow between 4 and 5.